ChatGerry The Physiology of Macro-City Survivability and Micro-Human Biology, number 1687, June 16, 2026, Gerald C. EclaireMD Foundation, category, Socioeconomics and Medicine. Preface: I have spent more than 3 decades traveling to and living part-time in Japan. Although I usually stayed only a few months each year, primarily in Tokyo, I also traveled extensively throughout the country, from Okinawa in the south to Hokkaido in the north. Over the years, I became increasingly interested in observing not only Japan's economic development but also the different paths taken by its cities. Some cities remained vibrant and energetic, while others struggled despite possessing rich histories, strong industrial foundations, and hardworking populations. As I reflected on these observations, it gradually began to notice similarities between the evolution of cities and the evolution of human health. At first, this appeared to be a simple analogy. However, after many years of observation and thinking, I came to believe that the similarities run much deeper. Both cities and human bodies are complex adaptive systems. This means that cities are made up of countless moving parts that learn and change over time. Both face crises, accumulate experiences, adapt to changing environments, and carry the consequences of their past. The examples of Kitakyushu and Fukushima particularly strengthen this belief. One illustrates survival after industrial decline, the other illustrates survival after catastrophic trauma. Together, they help me view urban evolution through the same conceptual lens that I use to understand human physiology. Cities and human bodies, at first glance, economics and medicine appear unrelated. One studies industries, employment, and finance. The other studies organs, metabolism, and disease. Yet both deal with systems composed of countless interacting components. Neither can be understood by examining a single moment in time. Their present condition reflects years or decades of accumulated history. This observation reminds me of a principle that has appeared repeatedly throughout my medical research. The present magnitude of a condition cannot be interpreted without considering the trajectory that produced it. A blood pressure reading, a glucose value, or a laboratory result tells only part of the history. The path leading to that measurement often contains more information than the measurement itself. Cities behave in a similar manner. Their current economic condition reflects decades of industrial development, educational investment, demographic changes, government policies, and cultural evolution. The deeper I examine this idea, the more convinced I become that cities and human bodies follow remarkably similar first principles. Both experience acute crises that threaten survival. Both suffer from chronic conditions that gradually reduce vitality. Both can survive catastrophic trauma while continuing to live under its psychological shadow. Most importantly, both possess memory. Kitakyushu survival is not recover. Kitaku provides a powerful example. For much of the 20th century, coal mining, steel production, shipbuilding, and heavy industry formed the foundation of its prosperity. The city became one of Japan's industrial powerhouses. As globalization accelerated and industrial restructuring reshaped the world economy, that foundation began to weaken. Steel production declined, factories closed, jobs disappeared, and younger workers increasingly sought opportunities elsewhere. The city faced a serious challenge to its future. From a medical perspective, this situation resembles a patient suffering a major heart attack or acute kidney failure after many years of chronic metabolic stress. At that moment, the central question is straightforward: can the system survive? Fortunately, Kitakyushu adapted. Environmental restoration transformed one of Japan's most polluted industrial regions into a model of sustainability. Tourism expanded, research institutions grew, advanced manufacturing returned. Semiconductor investment spread throughout Kyushu, creating what many observers now call Silicon Island. From a medical standpoint, this resembles successful emergency surgery. The patient survived. However, survival and recovery are not the same thing. A patient who survives heart surgery must still face rehabilitation, lifestyle adjustments, and long-term management of underlying conditions. Likewise, Kitakyushu continues to face population aging, declining birth rates, labor shortages, and the migration of younger generations. These challenges resemble chronic conditions such as obesity and diabetes. They rarely produce immediate collapse, but they slowly reduce resilience, flexibility, and reserve capacity. This distinction is important. Economic transformation may rescue survival, but long-term vitality depends upon continuous adaptation. Fukushima, beyond chronic disease. While Kitakyushu reminded me of mortality diseases and chronic conditions, Fukushima suggested a different analogy: the earthquake, tsunami, and nuclear accident of March 11, 2011 created a situation that cannot be fully explained through the framework of chronic disease alone. A more appropriate comparison may be cancer survivorship. Many cancer patients survive surgery, chemotherapy, or radiation treatment. Objectively, they may achieve complete remission, yet psychologically, life rarely returns entirely to its previous state. The possibility of recurrence remains in the background. Follow-up examinations generate anxiety. Minor symptoms attract attention. Future plans are often influenced by an awareness of mortality that did not previously exist. The disease may no longer be present, but the experience continues to shape behavior. Fukushima appears to exhibit a similar pattern. Roads can be rebuilt, buildings can be reconstructed, infrastructure can be repaired, radiation levels can be monitored and managed. However, confidence recovers more slowly. Many families relocated and never returned. Businesses delayed. Investment. Population decline accelerated. The average age of the remaining population increased. An invisible psychological burden became embedded within the community, and like obesity or diabetes, this is not merely a chronic condition, it is survivorship after major trauma. The immediate danger may have passed, but the memory of the event continues to influence future decisions. Memory is a hidden state variable. The deeper principle connecting these examples is memory. Human physiology contains many forms of memory. Blood vessels remember decades of hypertension. Kidneys remember prolonged exposure to elevated glucose. Bones remember mechanical loading. Brain remembers emotional experiences. Scar tissue itself is a physical record of past injury. Cities also remember. Infrastructure records industrial history. Population structures record migration. Housing markets record past policies. Investment behavior records trust and confidence. Communities remember disasters. Present function cannot be separated from accumulated history. 4. Both patients and cities. Memory derived from trajectory may be the hidden state variable that influences future adaptation. This observation extends beyond medicine and economics. It may apply to many complex systems, including psychology, engineering, business organizations, and even civilizations. Adaptation and survivability. As I thought about these examples, I realized that many discussions stop after describing disease, disaster, or decline. However, another stage follows: survival. Once a system survives a crisis, it acquires experience. That experience influences future decisions. Those decisions gradually become learning. Learning modifies behavior. Modified behavior improves the ability to survive future challenges. My own medical research followed this path. Health crises forced me to observe my body more carefully. Observation generated data. Data produced understanding. Understanding changed behavior. Those behavioral changes improved my survivability. The same process can occur within cities. Industrial decline can stimulate innovation. Disaster can stimulate redesign. Failure can stimulate education. History can become a teacher rather than merely a burden. The most resilient systems are not necessarily those that avoid injury. They are the systems that continuously transform experience into adaptation. Conclusion. Perhaps the greatest challenge for both medicine and urban planning is not simply survival. Survival is only the first step. The larger challenge is maintaining vitality after survival has been achieved. Kitakyushu teaches us that successful intervention does not eliminate chronic challenges. Fukushima teaches us that physical recovery does not automatically restore psychological confidence. Both examples demonstrate that the future depends not only on overcoming crises but also on adapting afterward. The body remembers. Cities remember. Families remember. Societies remember. Their future is shaped not only by what happened to them, but also by what they learned from those experiences. This may be one of the most fundamental principles shared by human physiology and urban evolution. The systems that thrive are not necessarily the systems that avoid adversity. They are the systems that learn, adapt, and continue moving forward while carrying the memory of the path that brought them there. For both a diabetic patient and a declining city, memory can either be a trap or a tool. If we just remember the trauma, we freeze. If we actively use the data from that trauma to change our daily habits, we achieve true vitality. This content is provided for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C.